So our last section of this chapter is being able to make predictions based off of our lines of best fit. So we're going to start with our warm-up here of being able to write an equation in slope-intercept form. So we're going to use our slope formula. And remember, our coordinate points are x and y. So we're going to subtract. So in this case, I end up with a -5 over -7. So 5/7 is my slope. Now I'm going to warn you guys, this one works out to not be a very nice number for our b value. So it's going to be a little bit tougher to find b in this case. So that's my slope. Then I'm going to take that along with one of these points. I'm going to use the smaller of the 2 points, just nicer numbers to work with. So I'm going to put that in as my x and y. And I know m. So my y is 2, my m is 5/7. My x is -5 plus our b. Now I'm going to multiply that, and I'm going to get a decimal. And I like a decimal for my b value because I'm going to be graphing it, or I would normally graph it. So I get a -3.57 when I multiply those two. And then to get b alone, we're going to move this 3.57 over. So now we have m and b, so we can write our equation. So in terms of finding our zeros here, so finding our zeros of a function, what the zeros they're talking about is it's the value value for x that makes y equal 0. So you might hear them use words like, so zeros, they also use the word roots. Solutions. And the other one is one we haven't heard for earlier since last chapter, is an x-intercept. That's also a 0, the function. So the value of x where y equals 0. So from the equation here, I'm going to put y in as 0 and find x. So I'm going to put 0 in for y. So I'm going to solve this equation by moving, I'm solving for x, I'm going to move the 12 over. So y is 0 because that's the definition. And then instead of multiplying, we're going to divide. So my x is going to be 4. Now from a graph, the x-intercepts is what we're looking at. So we're looking for the point on the x-axis. So this one is really easy. We just look at that point. That's where y is 0. My x is going to be 3. And then our last one here is for function notation. And if you recall, f of x is really like the same thing as y. And we're saying that equals 0. So we're just going to solve again like we did over here. So we're going to solve for x. So we're going to move 30 over. This is being multiplied, so instead we're going to divide. And we're going to find our x. So again, here they're just giving us specific values. So they're saying what value is y when x is -5. So in this problem, they're telling us to put x in as -5. So that's what they're giving us, that information. So we're finding y then. So times a -5. Now remember, order of operations, we multiply before we add or subtract. So we're going to do those two first. Negative negatives become a positive. And then we're going to multiply 4.2 by 5. And we get 21. And that's something you can just enter that whole thing into your calculator if you wanted to. Now, the next question is saying the opposite. This one says, for what x value is y 70? So now we're putting 70 in for y. So we're going to move the 8 over. So we're solving for x. We're getting x alone. And then instead of multiplying, we're going to divide. And I get kind of an awful decimal, and that's okay. So my x ends up being negative 14.76. And that's possible to get a decimal. It's perfectly fine. Okay. So we'll flip this over, and we're going to do a couple of problems here in terms of finding making some predictions. So this is baseball ticket prices for Major League Baseball from '97 to 2006. So this data is pretty old. So if you can kind of try to ignore that part of it. So we have a line of best fit they drew for us. What we're going to do is pick a couple points that we think it looks, first of all, it says determine the relationship, if any. What they mean by relationship is correlation. So it's a positive correlation. As the years go up, this increases, so does the price. So a year goes up, the price goes up. Everything keeps getting more and more expensive. So it's a positive uphill slope. So they want us to write an equation of the line in the slope-intercept form. So what we're going to do is pick a couple points that we think are good points to use. I like these two because they're kind of close to like a coordinate point. So my year here is 2001. And then 18 is the price. My next one is 2005 and 22. So I picked a couple that I thought were close to the line. And if you pick something different, it should work okay as long as you're not picking, like for instance, we wouldn't want to pick like those two. Like those wouldn't be good ones to pick because they're going too steep. So we wouldn't want to do that. So we're going to find our slope now. So y2 minus y1 and x2 minus x1. Well, we got lucky here. The ones I picked worked out really nicely. We get 4 over 4 as our slope. So our slope is just 1. Then we have to find our b value. So we're going to use our slope and then one of our points. So point and the slope, and we're going to put that in slope-intercept form. So we put those in x, y, and m. So running out of space here. So my 18 m is 1 times the year plus our b. So we're going to find out that b is a negative 1993. So our equation of our line of best fit now they want us to predict ticket price this year. Well, this data is kind of old. Why don't we predict a ticket price for this year? So our year, so the year that we're picking is 2024. And we want to figure out an average ticket price for Major League Baseball. So we're going to put that in as our x value here. 1 times 2024 is just 2024 minus 1993. And we should be able to do that. So the price of an average ticket is $31. And that's probably not that far off. And again, the year, or going up by $1 a year probably makes sense. So $31 is probably pretty reasonable. Our last thing here that we're going to look at is this roller coaster problem. I will apologize, this isn't the greatest example of a problem because of, again, the years, but also roller coasters can only get so high. At some point they can't be thousands of feet high. Well, I guess maybe they could, but it's a little bit tougher in that case. So it's probably not the best data. So years since 1988. So that means that years since 1988, so this would be 1989, add 3, so you kind of keep going up. We're across the bottom, I'm just going to go up by ones, but I'm going to label every other. We're going to be a little bit off for our 15 there. Up the side, I'm going to do what I call a break on the graph. So I'm going to break the graph because I don't need anything from 0 to 150. So I'm going to start at 150, and then I need to be able to get up to 400. So I'm going to call this 200. I'm going to go up by 25s. So this will be 250. This will be 300, 350, 400. Should be it. Put this data on the graph. You might wonder why there's 2 pieces of data at 12 years. Oh, there's 3. So maybe there was 3 new roller coasters being built, so there's 3 sets of data there. Oops. And then 15 is going to be up at 400. So I need to fit my data, my line to this. So kind of through this data, I'm going to try to draw my line as best as I can. Now, I think that fits the data pretty well, but at the same time, you might look at it and it doesn't hit any of the points. That's okay. We're going to kind of just pick a few points that seem reasonable. So I'm going to use the point here, because that looks like it would go through, and maybe right here. Those are just the points I'm going to choose. They're close to my line, kind of fit my data. So they're not actually coordinate points on my data information, so I'm going to use 5, 200. Oops. And 12, 325. So again, we're going to find our line of best fit. So my slope ends up not being a very nice number, so I'm going to call it 17.9 when I divide those two. So this is my M. I need to find B. So I'm going to use one of these points to find my B. We're using that to find B. I'm going to move the 89.5 over. So there's our B value. Once we have that, then we're going to take M and B and put it back into our equation. So there's our equation. Now, they ask us to make a prediction, predict the vertical drop in a roller coaster built 30 years after 1988. So we're going to do 30 years after 1938. So we're going to choose an X of 30. So we're going to put 30 in this value. So after 30 years, it should be the highest roller coaster should be this. I have no idea what the highest roller coaster is now, but that would be the prediction if this data continued on the way it did. All right, so homework is listed there. Hopefully that worked out okay for you guys.